Okay, here we are going to look at calculation involving preparation of solution. Okay, we start with molar concentration. Molar concentration, another name for molar concentration is molarity. There's the spelling, molarity. Okay, and it is equal to the number of moles of substance all over the volume of solution in dm³. So when I take a particular mole of substance and dissolve it in a particular volume of water, I can calculate or get the molar concentration. The next is mass concentration. Mass concentration is the mass of substance divided by the volume of solution in dm³. Okay, but now there is a relationship between molar concentration and mass concentration. And we see that here when we combine the two. We say that molar concentration is equal to mass concentration divided by the molar mass. Okay, molar concentration is mass concentration divided by molar mass. What this is saying is that if I know molar concentration, I can find mass concentration, and if I know mass concentration, I can also find molar concentration. Okay, so that leads us to a question here. It says, what mass of K2CrO2O7 is required to prepare 250 cm³ of 0.02 mole per dm³ solution? And we're given the molar mass. The molar mass is this. Okay. Here there are two ways in my mind here. First of all, we are given the molar concentration. Molar concentration. Molar concentration is also called concentration in mole per dm³. We are given molar concentration to be 0.02 mole per dm³. So here we can find the mass concentration. Since mass concentration can now be equal to the molar concentration multiplied by molar mass. Okay, when we cross multiply, so that's going to give us 0.02 multiplied by the molar mass is 194.2. 194.2. Okay, so I'm on my calculator here. 0.02 multiplied by 194.2, that's going to give us 3.884. So this will be 3.884 grams per dm³. Mass concentration is also called concentration in grams per dm³. Okay, now that we know the mass concentration, remember that mass concentration, let me use MC, mass concentration, okay, mass conc is also equal to mass over volume. Okay, now since the mass concentration is 3.884, so we are going to have 3.884 equal to, the mass is what we are looking for, we call it X, divided by the volume is 250 cm³. 250 cm³, if we convert it to dm³, is going to give us 0.25 dm³. So now you see that X now will be to cross multiply. We're going to have 3.884 multiplied by 0.25. That will give us 0.971. So the answer is 0.971. Okay, grams. So you can see that my answer here is A. Now, like I said, there is another way we can solve this. In that way, we can find number of moles first. Let's do that quickly. Okay, so we can find number of moles. Since we know that molar concentration is equal to number of moles all over volume, The molar concentration is 0.02. The number of moles we don't know, so all over volume. Volume is 250 cm cube, which when we convert to dm cube should be 0.25. So your x here will be 0.02 multiplied by 0.25. That will give us 0.005. So the number of moles is 0.005. Okay, moles. Now with that we can now find the mass, since we know that number of moles is also equal to mass over molar mass. So here the number of moles is 0.0, let's go back to what we have. Okay, the number of moles is 0.0005 equal to the mass is what we are looking for. The molar mass here is 194.2. So if we cross multiply, we are going to get the mass is 0.005 multiplied by 194.2. Okay, and that is going to give us the same thing. The answer is 0.971. You see, we use different methods to arrive at the same conclusion. So please take note. Now, another question here says a solution is prepared by dissolving 1.96 gram of H2SO4 in 250 cm cube of this solution. What is the concentration in mole per dm cube? Maybe we can get the concentration in grams per dm cube first. That's one way we can do that quickly. Concentration in grams per dm cube. They've already given that. That means 1.96, which is mass, the mass, all over the volume. The volume is 250 cm cube, which is 0.25 dm cube when we change that. So 1.96 divided by 0.25 is going to give us 7.84. So the concentration in grams per dm cube is 7.84 grams per dm cube. Okay, so now we can find the concentration in mole per dm cube. Since the concentration in mole per dm cube is equal to concentration in gram per dm cube divided by molar mass. So that will now be equal to 7.84 divided by the molar mass of H2SO4 is 98 when you calculate it. So if you have 7.84 divided by 98, we're going to get 0.08. So the answer is 0.08 mole per dm cube. Okay, so the answer here is B. The answer is B. Now we can achieve the same thing by finding the number of mole first. After finding the number of mole, then we use the formula. Let me do that quickly. Another way we can achieve the same result is by finding number of moles. So we're going to have number of moles is equal to mass over molar mass. So that would be 1.96 divided by the molar mass is 98 already. So when I divide 1.96 divided by 98, I get 0.02, so 0.02 mole. Now from this, now we can find molar concentration. The molar concentration or concentration in mole per dm cube is equal to number of moles over volume. So my number of moles here is 0.02. Now divided by volume. My volume is 250 cm cube, which is 0.25. So by the time we divide, we are going to get 0.08 mole per dm cube, or you just say still, just to show you different ways this can be achieved. Okay, so we now have another question here. It says calculate the number of moles of HCl present in 20 cm cube of a 0.75 solution of an acid. This is quite easy because the molar concentration is equal to number of moles over volume. Molar concentration here is 0.75 equal to number of moles is what we're looking for. Volume is 20 cm cube. If you convert 20 cm cube to dm cube, you're going to get 0.02 dm cube. So that means n will be to the cross multiply. And if we do that, that means 0.75 multiplied by 0.02. That's going to give us 0.015 mole. Okay, that will be the answer to the question. So the answer here is A. Beautiful. So this comes to the end of calculation involving preparation of solution. Thank you very much.